Hello, my name is Drew Overgaard. I'm an ECPE 71 Digital Design, and today I'll be showing you how to do number 3 on homework 6. So for part A, we're building an 8-to-1 mux using x1, x2, and x3 as select signals. So this means we're going to need to build a truth table. We have the truth table written out here. All we have to do is fill out the output values. So we have our max terms here, so every position that's in this list is going to be 0 for the output in our truth table. So we can go ahead and fill that out. Now that we have our truth table and our output values, we can go ahead and draw our mux, which I've already done. And we're going to want to put our selects here, S0 going to X3, S1 going to X2, and S2 going to X1. We've got our output F, and then we want to put each of these groups inside of the mux. So each of these 8 groups, because we divided the truth table into 8 parts, since it's an 8-to-1 mux. Now I drew this line here between X3 and X4, so you could see what those values are going to be in mux. So now we just need to draw the logic. We're going to need to figure out what each of these values is. In order to do that, we need to go 0, 0. We can use the intuitive approach, and if they're both 0, then it's going to be 0. If they're both 1, it's going to be 1. So we're going to get 0 there, we're going to get 1 here, we'll get 0 here. 1, 0, that's the opposite of what we have in X4, so we cannot X4. 1, 1, we get 1, 0, 0, we get 0, 1, 1 is 1. Down here, 0, 1, it's the same thing for X4, so we can just write X4. Now we know that we're going to have 0, 1, and X4 out here in our logic. We can start at the bottom, or top, I'll start at the bottom. X4, 1, 1, 1. And then we've got the next one, 1, 1, 0, that's 1. 1, 0, 1, that's 0. 1, 0, 0 is 1. 0, 1, 1 is X4 not, so we're going to have to draw not gate for that. Now we have 0, 1, 0, that is 0. 0, 0, 1 is 1. And 0, 0, 0 is 0. And that's how you complete part A for question 3. Number 3, part B asks us to make 4-to-1 mux using X3 and X4 as selects. So we're still going to need the same truth table here, but now this time we're going to need to group the truth table differently. So we're going to need to split it in half. Everywhere we have 0, 0, 0, 1, 1, 0, or 1, 1, those are going to be grouped together in X3 and X. Right here we have 0, 0, so that's going to be in the group 0, 0, another 0, 0, and the final one down here. Now, I've written out Shannon's here. This helps us figure out what our inputs are going to be and what the logic's going to look like. So wherever we have a 1 in each of these groups, we're going to include it. So for example, up here, we have a 0 in that group, so we don't include it. We have another 0 here. We have a 1 here, and that's X1, X2 not. So that's included. And down here we have 1, 1, X1, and X2. So you do that for all these different groups. Here's another group right here, 0, 1, 0, 1. And basically just do that for each of the 4 groups. Now down here, to figure out what our logic's going to look like, we can simplify that. We can take out the X2 and X2 not and X2. Since they're different, we get X1. Here we can take out X2, X2 not, same thing, we get X1. Here we can take out X2 not and X2 and we get X1 not. And finally, we can simplify that into an OR gate. Now that we've figured out what our inputs are going to look like, we can go ahead and draw the logic. X1, 0, 0. So X1's going to go 0, 0. X1's also going to go to 0, 1. X1 not will go to 1, 0. So we're going to need to draw a NOT gate here. And we have an OR gate for 1, 1. So that means we're going to need to get an input from X1 and X2. Draw the OR gate, and then put the NOT symbol there. And we've got the NOR gate going to 1, 1. And that's how you solve part B for question 3.